Okay, I'm going to let you guys do problem 5 on your own. I'm going to skip ahead to problem 6. There's just one step of work we have to do before we can make this look like all the other problems we've done so far. It's probably best if you're solving inequalities to get a 0 on one side. So what I'm going to do is I'm going to subtract 3x from both sides. Oops, and I copied this down wrong. This is a plus 4, not a 4x. Okay, so we have this quadratic, and we're asked the question, when is it less than 0? So the basic idea here is we're going to set it equal to 0 first, and we're going to find where this graph crosses the x-axis. We could do that by factoring, but I just got tricked, and this thing actually doesn't factor. I don't see two numbers that multiply to positive 4 that add to negative 3. I tried negative 4 and positive 1, but that doesn't actually work because those two numbers give us a negative 4, not a positive 4. So the only way to find where this thing crosses the x-axis would be to use the quadratic formula. I'll run through that really quick. And here is what I am seeing. When I try to work through the quadratic formula, I'm getting a negative under my radical. That would be a complex solution. Those are the numbers involving i's. So there are no real zeros to this function. What that means is the graph of this function never crosses the x-axis. Since it's a parabola that opens upwards, it must be up here somewhere. And you can graph this thing using your favorite graphing utility. I don't know exactly where it's located. All I know is that it doesn't cross the x-axis. So if we're asked the question all the way up here, where is this function less than 0? Well, it's never less than 0 because this function never goes below the x-axis. So there is no solution to this particular problem. I'm glad we did it. Okay, for this problem, we are given a cubic function. What you would need to do is move everything to the left side of the equation so you have a function less than 0. Then you could certainly find those zeros and graph this thing by hand. But what I'm going to recommend is graphing the remaining function in Desmos, see what it looks like, and decide where is it less than 0. Give it a go. See if you can do it. Let me know if you have questions. I'm going to fast forward through to problem 8. And to do problem 8, I think what I'm going to do is I'm going to start referring you to Desmos or to your graphing calculator. If we graph y equals 1 over x plus 20, and I'm going to move this graph so we can see this thing a little bit better, you'll notice that what we get is a rational function. It actually has an asymptote you can see right here at negative 20. It's a vertical asymptote, which you would expect given that denominator. It also has a horizontal asymptote at y equals 0. Again, which you would expect given what we know about horizontal and vertical asymptotes. But here is what our function looks like. What the question is asking is, for which x values is this function greater than 0? So I'm going to take a screenshot of this thing. I'm going to paste it right here so that I can draw on it. And if we're wondering where this graph is greater than 0, that means where is it above the x-axis? That is for this entire piece of this function right here. Now, to actually answer the question in my math lab, they're first going to ask us for the critical values of this function. And to put it in as simple terms as I possibly can, if you want to find the critical values of a rational function, you can find those by finding all of the values where the numerator equals 0 and combine those with where the denominator equals 0. So if our function is 1 over x plus 20, the question is, where is the numerator equal to 0? Well, the numerator is 1 and that never equals 0. The next question is, where is the denominator equal to 0? And the denominator equals 0 at x equals negative 20. So that is the only critical value in this particular problem. Now we can actually find the solution set. You can watch the video lecture to hear a little bit more about critical values. I'm going to use this graph and I'm going to say, okay, the question was asking where's the function greater than 0? This pink area is where this function is greater than 0. What are the x values? And that is the solution set. Well, those x values go from negative 20 to infinity on this piece of the graph right here. Notice we're not including negative 20 because this asymptote is never touched by the graph. I'm going to hit enter on that, and that is going to be our answer. Well, this is nice. This function is actually graphed for us, so we don't have to do any work. We can just find the answer from this graph. Here is our function that is graphed to the right, and we're asked where is it greater than or equal to 0. Well, again, I'm going to take a screenshot of that and move it over here, and I'm going to look at this graph and say, where is it greater than or equal to 0? Well, this graph is equal to 0 right here, and it's greater than 0 up here. That's where its y values are above the x-axis. Also, right here, the function is greater than or equal to 0. So we just need to write down the x values in these pink regions here using interval notation. This first pink region right here looks like it goes from -4 to 0. Now -4 is on a vertical asymptote, so the function actually never touches vertical asymptotes, so it never touches -4. So this pink region goes almost all the way to -4, but not quite, so we're going to use a parenthesis here. And this pink region goes to x equals 0, and we're going to use a bracket there. We get that bracket because we had an equal sign on this inequality. Now we have a second interval over here we need to write down as well. So I'm going to use a union, and this interval goes from +4 off to infinity. That looks like a good answer. Let's move on. This problem is simply asking us, where is this function greater than 0? So what I'm going to ask you to do is I'm going to ask you to graph this function, take a look at the graph, and then do the same thing I did right here. Ask, where is that function greater than 0? And see if you can come up with a solution. Let me know if you have questions. The same is true for problem 11, so I'm going to let you graph that and try to figure the solution out on your own. Problem 12 is the same, so I'm going to move all the way ahead to problem 13 in this set, because they ask us to find the critical values for this inequality. And again, what I said about critical values up here still is true. The critical values are just the numbers, the x values, where the numerator equals 0 or the denominator equals 0. So if we set the numerator equal to 0, well, that's just -1 equals 0, which is not a true statement, so that's not going to give us any critical values. However, if we set the denominator equal to 0, we do get an x value. We can subtract 9 from both sides, and we can divide both sides by 2 to get -9/2 as our critical value. Okay, you can learn more about critical values from the videos for the lectures for this section. But I'm just going to go ahead and try to answer the rest of this question. If we create a graph of this function, it's going to look like this right here. And maybe not too surprisingly, there is a vertical asymptote at -9/2. That would be -4.5. That's that vertical asymptote right there. And we are asking with this inequality right here, where is that function less than 0? Well, less than 0 means below the x-axis, so the function is less than 0 for that entire thing right there. What are the x values here? Well, the very smallest x value gets really, really close to this vertical asymptote of -9/2. The function never touches -9/2, so we're not going to include that in our interval. And the largest x value actually goes off to infinity. So this function is below the x-axis for all of these x values from -9/2 all the way up to infinity. And that is going to do it for that problem. We have a few tough problems to do at the end of this section, so I'm going to create a new video for those. I'll see you in the next one.